So machine learning is the idea that some algorithms can tell us, well, interesting things about our data without explicitly being programmed to do so, which is the traditional way in which computers run. So instead of writing code, we feed data to the algorithm and it builds some kind of logic, be it some classification logic or things like that. Now, let's start out with kind of an example of classification logic, because that's kind of a neat one, right? I'm going to give it a bunch of data, and the machine learning algorithm will put it into a bunch of groups. And maybe it'll identify a letter, maybe it'll identify a spam email, maybe it could identify an abnormality in an MRI scan for a tumor, or maybe it'll identify a picture of a ski boot. You know what's interesting? All four of those use cases use the exact same algorithm. There's no code changes. The only difference is we give it different data and out comes different classification logic. So in machine learning, there's kind of two branches of it where all kinds of algorithms flow into. Supervised learning and unsupervised learning. And in supervised learning, we give it the training data. In other words, we know the answer, and we're going to help the computer learn and discover more answers. So imagine if I wanted to create an algorithm that could go and scan anything and find the letter A. I would go and find, 100, 200 A's, as you can see here. Now, there's probably millions of A fonts in the world. I don't need all that, right? I need a kind of training set. Here's my training set of A's. I would run it through the algorithm, and of course, under the covers is mathematical operations going on here, right? It's looking at the curvatures and lineations of these symbols, and it would come back with these learnings expressed mathematically, and here I've kind of abstracted them, that every A has an apex. And in the center, most A's have a triangular shape, could have a quadrilateral, but a triangular shape, right? They have 2 feet, those feet could be pins, and they typically have a bridge. And then I can take that algorithm and scan text, and I could scan pictures, and if I wanted to go and figure out who had A's in them, this is exactly what it would do. This is the exact same algorithm behind face detection, behind handwriting detection, and those types of things. So, the other kind of machine learning is called unsupervised. This is where we have no idea about the data. So I'll just keep with our example. Imagine the computer, without me telling it, doesn't know anything about letters. And let's say you didn't speak English. And I had a bunch of letters. And so I'd ask the machine learning algorithm to go here and create some classifications. Now I could use various types of algorithms, a k-means, or get more types of levels of support with an SVM, a support vector machine type algorithm, to go and create classifications. And the first classification that came out of my algorithm here was this. Now, if you speak English, and you know the alphabet, right? You know that C and O are different letters. But mathematically, they're very similar. That's another concept in machine learning called nearest neighbors. And you can decide how close do you want these neighbors to be. And that's the exact type of algorithms that Walmart will use to put out a store, that a school planning would go from public service and public government communities. And the C and O are pretty close, as are the Z or Z and X. And then maybe I wanted it to be a more granular algorithm, so I ran it through again. Maybe I gave it more data, and now all of a sudden I have 6 different clusters. So this is kind of machine learning going from an unsupervised. And as I now kind of confirm what I've got here, right, now I take these learnings and I can take it to another level. Now I can take my machine learning algorithm and focus on the A's. But now it's supervised, so these two mix together, right? And in the supervised model, what happens? Well, I've discovered these patterns or repeatability of shapes, and now I can go and start to identify the fonts within those shapes. And this is exactly the technology when you take a picture, upload it to the internet, and it tells you what fonts are used in the picture, right? So there's a great example of machine learning. Now, there's some confidence behind machine learning, and we call it scoring. I'll just give you a quick overview of that. Imagine if I built an application that wanted to go and find cats in pictures, and I gave it these 12 pictures, right? And you can see here, 5 of them are cats. So this is obviously a what? That's right, it's a supervised set. And imagine if my application came back, or my algorithm, I'm training this algorithm, it's going to be exposed over the web through a REST API, right? And it came back like this. You can see that I asked for all the cats, and 2 of the pictures are cats, and 2 of the pictures are not cats. Although it's a really cute hippo, right? Okay, so the concept of math behind that would be the precision. The precision is a measure of accuracy or exactness. And in this case, our algorithm has about 50% precision. And the recall is a measure of coverage. That means in a supervised model, because I know all the outcomes, how many did I get right? Or how many did I miss, actually? And in this case, I missed 60% of the cats. That's not a very good algorithm, is it? But that's okay, because we fail fast and we learn. And how does this work in application? Here's a real application. IBM built it. You can go access it. Loaded in hundreds of thousands of sporting pictures. And we didn't tag them. We didn't go to iPhoto and say, here's the skiing picture, right? What did we do? We taught it a training set of what alpine skiing looks like, of what snow looks like, what a snow sport looks like. And then I can come in here, search on alpine skiing, and what do I find? All these pictures with these auto classifications and these confidence intervals. And you know what? Some of those pictures are wrong. It's not alpine skiing. It looks like bobsledding. But guess what? That's about training the model, right? So not everything's going to be perfect in the models. They're going to get smart. Some of them I can identify, and I identified it as a snow sport or skiing. So auto-categorization. Huge use case in homeland defense. Huge use case in policing. Huge use case in retail.